Let's continue talking about properties of square roots. So one property that we want to be able to use is recognizing which perfect squares another number is between. So just to recap, it's really important for this chapter and really future chapters too, that we know our perfect squares. So these are numbers, that can be written as a number squared. So for example, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25 is 5 squared, 36 is 6 squared, 49 is 7 squared. And I'm going to go up, I see the first problem we're going to be working on goes up to the 80s, so let's go up to 100 on this. So this was 7 squared, 8 squared is 64, 9 squared is 81, and then 100 is 10 squared. So this list of perfect squares, we're going to need to be able to recognize these relatively quickly and painlessly. So if you don't have them memorized already, it's not like a list in order, but just to think about, okay, what are perfect squares, and to be able to rattle off at least the first 5 here. So 84, the square root of 84, since 84 is between 81 and 100, we know the square root of 84 must be between the square root of 81 and the square root of 100. So what this gives us a way of doing is estimating square roots without a calculator. And so that's what example 4 is. So this list of square roots we should be able to do without a calculator. But square root of 84, I don't know, that's not a perfect square. So I'm not sure what that is. But what I can say is that square root of 81 should be less than the square root of 84, should be less than the square root of 100. All right, that's an order because 84 is in between 81 and 100. Well, I know square root of 81 is 9, and I know the square root of 100 is 10, so that means the square root of 84 must be between 9 and 10. Now, the only thing that's left here is this negative. So I just need to make everything negative, but when I do, this inequality needs to flip. So this still says that square root of 84 is in between negative 9 and negative 10, but this time negative 10 is the smaller number. Once we make an inequality negative, we gotta flip the inequality sign. So let's check and see if that's right. So I got a calculator, turn it on, 84 square root, and then of course you can use the negative button to make it negative. So yes, 84 square root of 84 is between negative 9 and negative 10. And because 84 is close to 81, you can see it's close to negative 9. All right, let's try the next one. It says 2 plus square root of 3. So I'm going to start with just the square root of 3 and trapping it between two perfect squares. Now, 3 is actually below this list. I didn't start my perfect squares as low as I should have. 1 is the first perfect square because square root of 1 is just 1. Plus square root of 3, or not plus. We're just saying that the square root of 3 now is somewhere between 1 and 2. Probably a little closer to 2 since 3 is closer to 4. So now it's just, well, what do I do with this 2 plus? Well, I can add 2 to all sides. And that's not going to flip the inequalities like the one we did before. We can just add 2, and add 2. So this means, right, so 1 plus 2 is 3, 2 plus 2 is 4. So 2 plus square root of 3 must be between 3 and 4. So let's check it out and see if that's true. So I do 2 plus 3 and then square root equals. And 3.732 is indeed between 3 and 4. So we can estimate what that is even without a calculator by using our perfect squares. Let's do one last example of this, which is square root of 20. Square root of 20 should be between, if we look at our list of perfect squares, 20 is between 16 and 25. Square root of 16 is 4. Square root of 20 is what I don't know. Square root of 25 is 5. So we know square root of 20 is somewhere between 4 and 5. And it's probably like right, you know, close to the middle, since 20 is almost as evenly close to 16 and 25. Now this one, now what they want us to do though, is flip this into a fraction. So 3 divided by 4, 3 divided by 5, and 3 divided by square root of 20. Flipping fractions is sort of like the multiplying by negative, where 3/5 is 0.6. That's actually less than 3/4, which is 0.75. So reciprocating, like what we sort of just did to get that 3 on top, flips the inequalities just like multiplying by a negative does. So this says that 3/20, or 3 over square root of 20, sorry, we need the square root in there, that's the whole idea. 3 over square root of 20 is somewhere between 3/4 and 3/5. Or if it helps, you can think of it as 0.6 and 0.75. So let's try it, see if that's right. 3 divided by 20 square root equals 0.67 is in fact between 0.6 and 0.75. So it works out, but this is how to estimate these kind of expressions without a calculator, is by using perfect squares. All right, let's do some other properties. The two we're going to be using the most often, actually the most often, is the multiplication property for square roots. The idea that if you multiply two square roots, you can combine them into a single square root. It also enables us to go the other way. If we have a single square root, we can actually think of it as two separate square roots. Same works for division. If you have two separate square roots being divided, you can combine them into one square root. Or if you have one square root with a fraction, you can think of it as two separate square roots. So let's see what this looks like. Actually, let's just demonstrate that it works, right? We're going to use 4 and 9. So I'm going to let x equal 4 and y equal 9. And we're going to use these properties here. So the multiplication property says square root of 4 times square root of 9 should be equal to the square root of 4 times 9. That's what we're checking out. So if I do the square roots separately, we would get 2 times 3. And if we do them together, we would get the square root of 36. Right, so we're using order of operations here. So order of operations in this case would say do the square roots first. But on this one, it would say do the multiplication first. And we end up with the same number both ways. That's really what we are trying to show. Let's do the same thing with division. Division. So this time we want, instead of square root of x, we're going to use square root of 4 and square root of 9. And we want to know, does that equal the same as the square root of 4/9? This one's a little weirder to demonstrate because usually, at least how I teach this, is that to do the square root of 4/9, we would do the square root of 4 over the square root of 9, right? And that way we would get 2 over 3. So instead, to check this, let's use the calculator. So I'm going to type in 4 divided by 9 equals, get that, so that's the 4/9, and then just press the square root button. 0.6666 repeating. Is that the same thing as 2/3? Hopefully we know that's the case, but if not, you can just type 2/3, and yeah, 2/3 is 0.6 repeating, so that also checks out. Now, what we might not have thought about is that there is no addition subtraction property. So addition subtraction does not simplify with square roots. I'll just say, yeah, I'm just going to say does not work for now, because there are ways we can simplify it, but we're not going to be able to do sort of the same kind of property with multiplication and division. So for example, if I have square root of x plus square root of y, we cannot say that that's the same as the square root of x plus y. It never works. Maybe there's like one particular, if we use like ones and zeros, maybe this would work. But let's try with the 4 and 5. So we got square root of 4, square root of 9. I said 5 to 9. We're using x equals 4, y equals 9. So square root of 4 is 2, square root of 9 is 3. And we want to know, does that equal the square root of 4 plus 9? The square root of 13 is not the same as 5. Right? I can put 13 square root. It's not even relatively close to 5. So this just does not work, and it wouldn't work with subtraction either. All right, so now that we got these couple properties, let's use them. And the way we're going to use them is to simplify square roots that aren't square roots of perfect squares. So we saw how to estimate like what two numbers this was between. Right, square root of 50 is close to the square root of 49, so it's close to 7. But this time it doesn't want us to know what number it is, it just says simplify. So what we're going to do when it says simplify a square root is look for perfect square factors. Perfect square factors. And hopefully you have that list at the top of your page because we're going to need it. Another thing that I sometimes do is just write out a list of perfect squares. 4, 9, 16, 25. Those are really what we're looking for. So let's look. Square root of 50. Do any of these numbers, these perfect squares, go into 50? Yeah, 25 does. So we're going to instead write 50 as square root of 25 times the square root of 2. And that's because 50 is 25 times 2. We're specifically looking for a perfect square. And the reason is because I know the square root of 25. It's 5. And the square root of 2 doesn't simplify, so that means we're done. And the way to tell if a square root simplifies is, does a perfect square factor into that number? So 4, 9, and 16 do not go into 2. So that's how we know we're done. We're going to do a few more examples because this is a little weird for sure. Let's try the next one, 60. So we're looking for one of these to be factors of 60. Well, I'm not sure about 9, 16, 25, so let's do 4. If in doubt, try dividing by 4. You get 4 times 15. So in other words, we're going to do square root of 4 times square root of 15. And you can definitely use a calculator, right, if you didn't know that. The nice thing about this is that we're only checking probably like 4 numbers. So you could just do 60 divided by 4 and it works. 60 divided by 36 wouldn't work, right? 60 divided by 25. You're just checking these perfect squares and looking for one that goes in a whole number of times. So we found our perfect square. Square root of 4 is 2. And then 15 is not a perfect square, and none of these other perfect squares go into 15. So that means we're done. And let's try C. This negative out front does not do anything for us. Doesn't really change the problem. So we just need to find a perfect square that goes into 12. There's not many choices here. It's 4. So I have negative square root of 4, square root of 3, because 4 times 3 makes 12. And I'm looking for 4. We wouldn't want to write this as 2 times 6 because neither of those are perfect squares. We want one of these to be a factor. And that's because I know square root of 4. It's 2. The negative just hangs out in front, and the square root of 3 doesn't simplify because there's no other perfect square that goes into it. So we're done. So hopefully you're getting the hang of these, but let's try a few more just in case. Square root of 48, we gotta look for one of these to go into it. And ideally, you would notice that 16 goes in there, but I'm gonna show you what would happen if, let's say I didn't see 16, I was just going, well, 4 goes into it, so let's do that. So 48 would be square root of 4, square root of 12. So again, you can always do 48 and then just divide by 4 to know if 4 goes in there. And square root of 4 is 2. But square root of 12 is not done yet because 4 goes in there again. So if you see that a bigger perfect square that goes into 48, you only need one step. But since I didn't see it, I gotta do this again. 12 is 4 times 3. So we gotta do this again. 2 times square root of 4 is 2, and then we just have a square root of 3. These are all multiplied. We're using the multiplication property for square roots. So my final answer is 4 square root of 3. And again, we could have gotten there, sorry, I'm off the screen here. 4 square root of 3, and we could have gotten there quicker if we had seen that 16 went into 48. But if we don't see that, no big deal, we can still get there. It just takes us a couple more steps. All right, let's try 500. Now, 25 definitely goes into 500, but I think there's a larger perfect square that goes into it, and it's 100. So again, quicker, the more you see a larger perfect square that goes in there, the quicker the problem might be. But you could still get it right using 25 times whatever, how many over times 25 goes into 500. But 100 times 5 is 500. Square root of 100 is 10, and so that's it. The answer is 10 square root of 5. This last one isn't too bad either because it's not on my short list over here, but 36 I know is a perfect square. So that's why it's important for us to be able to recognize perfect squares to get these to go easier. So I'm going to write 360 as 36 times 10. Anytime something ends in a 0, that means 10's a factor, so 36 times 10 is 360. The negative just stays out in front, and I know I'm done because no other perfect square goes into 10.